Your application is probably 70 to 90% open source code that you didn't write. Every one of those libraries is a door into your system, and most companies have no real idea what's behind those doors. Today, we're talking about software composition analysis, why it matters more than almost anything else on this list, and how to manage it without slowing down development. Let's start with why this is the highest leverage risk area. You've probably heard about major security incidents where a single vulnerable open source library used indirectly across thousands of applications turned into a global event almost overnight. That's the dependency problem in a nutshell. Most teams know their direct dependencies, the libraries they explicitly added to their project, but they have very little visibility into their transitive dependencies, the dependencies of their dependencies, which can go dozens of layers deep. There's also a license risk dimension to this that often gets overlooked. Using a library with a restrictive open source license inside proprietary software can create a legal problem, completely separate from any security concern. So what does software composition analysis, or SCA, actually do? First, it builds a software bill of materials, often called an SBOM. This is a complete inventory of every component, every version, and every license used in your application. Second, it cross-references that inventory against vulnerability databases. Things like the National Vulnerability Database, the GitHub Advisory Database, and various vendor feeds to identify known vulnerabilities. Third, it flags outdated versions even when there's no known vulnerability yet. Being 40 versions behind is itself a risk signal. It means future updates will be harder, and the gap between you and a secure current version keeps growing. And increasingly, SBOMs are becoming a standard requirement in vendor security questionnaires and even in regulation. So having one ready isn't just good practice, it's becoming an expectation from your customers. Now let's talk about the triage challenge, because not every vulnerability flagged in a dependency is actually exploitable in your specific context. The real question is, does your code actually call the vulnerable function or feature? Some modern SCA tools perform what's called reachability analysis, assessing whether the vulnerable code path is actually used by your application at all. A practical prioritization framework looks at a few questions. Is the affected component internet facing? Is it a direct dependency or a transitive one? Is there a known exploit actively being used in the wild? And is the fix a simple patch version bump or a major version upgrade that could break things? There's also something worth naming directly: dependency debt. Teams that defer updates accumulate risk that becomes exponentially harder to address later, both technically and in terms of security exposure. So how do you build a sustainable process around all this? Automate SCA scans as part of your continuous integration pipeline, but also run periodic full dependency tree scans. This matters because transitive dependencies can change even when your own code hasn't, simply because upstream projects release new versions. Establish a regular update cadence, for example, a monthly dependency review, with a separate fast-track process for critical vulnerabilities that need immediate attention. and maintain your SBOM as a living artifact, not a one-time report. It becomes incredibly useful during incident response. When a new vulnerability is announced and you need to quickly answer, are we affected by this? It's also useful for responding to customer due diligence requests. To wrap up, third-party library risk is invisible until it isn't. RiskRecap takes your software composition analysis results, helps you separate the noise from the real exposure, builds out your SBOM into something usable for customer security questionnaires, and tracks your dependency risk trend month over month in your risk report.